Hello everyone, my name is Sam Lane. Welcome to today's lecture. Today I will be presenting about PV system dependencies on environmental conditions and site access. So the references we'll be using today are NREL's 2018 Operations and Maintenance Best Practice Textbook. So that'll be where the bulk of information from today's lecture comes from. I will also be focusing on two research articles that will supplement the text book. So that's by Name in 2014, and then Ryberg, Severin, and Freeman in 2017, talking about soiling models and then also snow cover models. So when we think about environmental conditions, what kind of things are we thinking about? So the main one is that people generally talk about is soiling. And so that'll be a big part of the lecture today. We also have things like humidity, hot climates, high wind, hail, heavy snowfall, which is also important and we'll cover pretty in depth today, and things like flooding or big natural events like flooding, hurricanes, things like that. So many of these things are obviously outside of human control. Soiling, that one can be addressed by operations and maintenance. That's why we'll cover it pretty in depth today. And that's usually managed through cleaning, and you can also manage it during the site selection process. Another one, humidity, that one can also be addressed through O&M by installing dehumidifiers and shelters that contain sensitive equipment. So soiling. The biggest thing, so soiling reduces energy output of a PV array. So if possible, when you're looking at two different sites, and the only difference is that one has a source of soiling and the other does not, we definitely want to choose the site with no soiling problem. And that's what we mean here. It's best to address this during the site selection process so that you don't even have to consider it when it comes to operations and maintenance. Another thing to consider is that uneven soiling can lead to localized hotspot failures. So kind of think about bird droppings with big bird populations. That's something that you would have to be concerned with. So, if you weren't able to address it during the site selection, it can be addressed through operations maintenance by cleaning. The major sources of soiling are agricultural dust, construction dust, pollen, birds, and industrial sources. So things like pollen and birds may be a little more outside of the control in terms of site selection, but you can definitely select sites that are, maybe a bit removed from the agricultural dust, construction dust, and industrial sources. So here, this is what we were talking about earlier with bird population source of localized soiling. Um, so you can see here, bird droppings all over the panels. Those can lead to localized hotspots and can cause damage to the panels, or major inefficiencies in PV output. So cleaning. So care must be taken with array cleaning to avoid damaging components. So that's very important. Usually PV module manufacturers have recommendations regarding array cleaning. And in general though, you want to clean PV modules with plain demineralized water and mild detergent. And usually manufacturers will recommend, what type of detergents to use. So, the main economical method of cleaning is just a bucket of water, cleaner and a squeegee. Kind of think about, cleaning your car windshield, kind of the same concept. So what you want to avoid is using high pressure water, brushes, or solvents, abrasives, harsh detergents, things like that. For larger commercial systems, robotic cleaning systems come into play. And so that's something that you can think of in the design process. If you know you're in an area that's going to require cleaning, going ahead and designing that before you ever start building can really alleviate some operations and maintenance costs. So the next question we have to ask is, what is the optimal cleaning interval if we do have to clean? So a lot of times you'll see cleaning defined in certain intervals for larger systems, or you could see kind of, on the spot cleaning, the system's dirty when you go clean it. So in either case, the benefits of cleaning can be hard to calculate. So for example, if you're not doing an interval cleaning and you have some type of system that's going to indicate when the array is dirty, to trigger cleaning, you may have a heavy rain the next day that would clean the array for free. So you just kind of messed up. But in the case of a uniform soiling, a local site-specific cost-benefit analysis should be performed to determine whether routine cleaning of the array is warranted. So the frequency of these intervals, it can definitely be seasonal. It can depend on local rainfall and dust characteristics. And so the optimal cleaning interval is affected by several parameters listed here, mainly the cost of the cleaning, how fast the soil is accumulating, the capacity factor for your given location and the value delivered, and then also how efficient the PV modules are at the given location. So it's very tempting to just combine all those parameters we just talked about to calculate a cleaning interval that justifies the cleaning expense. However, because dirt begins to accumulate again as soon as the system is cleaned, and because of rain and the unpredictability of rain, a simulation-based approach is required to account for those time series effects. So how often it rains, how fast dirt accumulates, and using simulations, you're kind of able to determine the best interval. So a study in 2014 in Mesa, Arizona, looked at, what's the optimal times to clean a large commercial plant. And so in this study, they determined that if you clean it once, you could lower the losses by 1.91%, or sorry, from 1.91% to 1.52%, so down 20%. 2 cleanings would lower it down 31%, and then 3 cleanings would lower it 37%. So, you might think, is that worth it? So we're talking about, the soiling losses were 1.91% without any cleaning, and then with 3 cleanings a year, it goes down to 1.2%. So is that 0.71% loss worth it in the long run? And so this study in 2014 actually determined that no, it's not worth it. Either residential, commercial, utility, PV plants cleaning is not worth the cost. So most plants are relying on rain to keep their array clean, and no cleaning regimen is employed. So now that we've talked about soiling, we'll move on to another important environmental condition, and that's snow. So snow accumulation can result in major performance reduction, but the accumulation is typically accounted for in the design phase. So the 2 things you can do in the design phase are the slope of the panels. So if you're greater than 20 degrees, that really helps, the snow slide off the panels, and then also ground clearance. So you have to have enough room between the bottom of the panel and the ground for that snow to accumulate. And then, if you do actually have to go remove snow, if you didn't account for this in the design phase, you definitely could potentially damage the cells. But it might be necessary if you have a big snow that you weren't really expecting or you didn't plan for in the design phase. So another study we're going to look at is the Ryberg and Freeman study in 2017 that looked at average snow losses as a percentage of annual energy production. And so these are snow losses with utility scale plants with a tilt of about 20 degrees. And so we see that only very small percentage of area in the U.S. has 10 to 16% losses. Pretty much everywhere on the West Coast and the South, where solar is really popular, is actually 0 to 2% losses due to snow, which makes sense. Where there's a lot of sunlight, there's not a lot of snow. But as you go further north, snowfall is definitely something you got to consider. So the last environmental condition we'll talk about is extreme weather. So this is things like tornadoes and hurricanes. So hurricanes in the Caribbean, storms along the eastern U.S. coast, tornadoes in places like Texas and Oklahoma. So these are things that could definitely affect PV systems. So the biggest thing is to, again, we keep pounding this, is risks need to be identified in the design phase. So things like 2-column racks, thick or non-glass covers on panels, rigid back sheets, thorough bolted clamps are super important to, if you're building in an area where you risk extreme weather, you got to plan for those things. And then if you do have a PV system that is affected by extreme weather event like a hurricane, there's specific things you have to go in and do. So you have to, first of all, make sure you have the right people that are trained and certified to go in and work on the systems that might have potentially been damaged. Obviously, there's electrical safety concerns, and then also just physical safety concerns with things being blown around. So they'll go in, render the system is in a safe condition, and then make any repairs that are necessary, evaluate, make repairs, and then you have to recommission the entire system after. And then the last thing we'll talk about in this lecture is site access. So utility scale sites require access roads between arrays to facilitate construction services. So these big plants, you have to have roads to get things like cranes in. It's very important. And then also planning for emergency vehicles to be able to come in, cranes to not only during the construction phase, but for O&M purposes to be able to come in. And then just maintaining those roads periodically have to be factored into the operations and maintenance costs. Another thing to consider is site security. So if you're in a more populated area, things like cameras or occasional visits by a security guard might be warranted in those areas. So that's it for the lecture. Environmental conditions and site access are a super important part of operations and maintenance planning. Thanks.